While you guys have all been playing Zelda, I've been working on a new feature that I hope you'll like. I think it's pretty cool. I thought it warranted a video to kind of get a visual idea of how it works. The feature is motivated by the fact that we have a couple really good players, and I feel like some players are getting discouraged because it's hard to compete against the really, really good players. And I thought maybe one solution to that is to have a way to easily split people into teams and an algorithm behind that helps to figure out what the best teams are given the current players on the server. So let's just give you a little demo of that, and then it'll become more clear what I'm talking about. So if you type just the command teams, it will split the team in two, or will split all the players into two teams. And what you see on my screen here is players of different rank. The higher number equals a higher ranked player. So this player with a 2100 rank is much better than everybody else, and the 900 rank is much worse than everybody else. And then 1500 is kind of the middle in this example. So we have a couple players, we have like three players, 14, 15, 1600. They're all about the same talent level. And then as you go down, you have an 1800 who's, a fair bit better than the 1500s. And then the 2100 is a lot better. So when it makes teams, like in this case, we're making two teams, what it does is it splits it up. It kind of does a round robin sort of approach. It takes the highest ranked player and puts him in the red team, and then it takes the 1800 and puts him in the yellow team, and then it takes the next player and puts him in the second team, and so on and so forth. And so it tries to split it up in such a way that it balances the players altogether. In this example, you see we get three players in each team, where the best guy gets a couple of the lower tier players, and so there's three players on that team, and then there's four players on the other team. And let me do a couple more examples. So what if you decide? So that's the default teams argument. If you type it with no arguments, it's basically equivalent to red and yellow. So that if you want to do yellow and red, you can do that as well, and then it'll just flip those colors. But what if you have red, yellow, and blue? What if you have three teams? How is that going to split? It kind of does the same thing. Starts with the best player, puts them in the yellow team, puts the next player in the red team, the next player in the blue team. And then at this point it says, well, the blue team is the weakest, so I'm going to add the next player into the blue team. And then it evaluates it again and says, well, the red team is now the weakest one, so it adds one there. And then these two very weak players end up in the yellow team. So you end up with a fairly distributed set of teams. You can even go up to four teams, so or more. So if I go four teams in this example, it follows kind of the same pattern: red, yellow, green. So you can see red and blue each are their own team, and then green actually has three players, but they're all kind of medium to lower tiers, and then the yellow team has a couple of medium tier players. So the more you split it, the less accurate it is, and it's hard to say one player is going to be competitive with three of the lower tier players, but it may well very work out. We'll see. So let's say that the best player 2100, let's say that he wants to take a break. So I'm going to put him away, and then I'm going to do that again. And then you can see it splits it up differently. Actually, let's go down to three players because that's more interesting. You can see it's kind of logical where the blue team is the best and the worst player together, and then the second best and the second worst player together, and and then the two mediums are together. So you can see that that seems like a pretty logical split of the teams. And then you can also go down to 2, and you'll see that it'll split fairly reasonably. So you get 3 and 3. So when you get something that's easily divisible by 2 or 3, then the results are a little bit more intuitive, I would guess. As you might have guessed, that these numbers are meaningful. I'm going to put player 7 back in the game. These numbers on the players are basically what's called ELO rankings. ELO is a system that originally was used to rank chess players, and it's now used for a lot of different things. Like 538 is using it to rank basketball teams and football teams and other things of that nature. So the concept of ELO, and actually more generic versions of ELO, are coming out that are used to rank players, and that's what I'm using here. I'm using an ELO system, and the numbers are stored in, let me show you where I have the numbers stored. I'm storing them in player ratings.json. And you can see here I've got the player names, and so for instance, player 900, there's his name. He's played 0 games, and his rating is 900. I just made this up for this example so you can see how it splits the teams, but one other thing that's behind this new feature, behind the teams player, is the ability to learn player skills. So this is a made-up example, but I have actually been running this version for about a week now and joining games to try to learn different player strengths, and so that the algorithm will learn over time. It takes about, I don't know, 40 to 60 games, somewhere in that range, to get a good, for the algorithm to get a good idea of how good each player is. And then after about 60 games, it sort of settles into what the player's true talent level is. And if you get better, your ranking will go up, or if you get rusty, your rating will go down. It stores that all locally on so each instance of Avara running will have this player ratings file go. So it really depends on who you play and how often you play, your rating. And so when we serve these games and want to use this command, we might want to use whoever has the most extensive database of player rankings. But I thought this is something I've always thought would be fun to do. There's no incentive, I don't think, for people to inflate their ratings, because if they inflate their ratings, they're going to end up putting themselves in the wrong team, or they're gonna be on a team where they lose. Or conversely, if you lower your ranking, you're going to end up on the wrong team as well. So we'll see how it goes, but I don't think anybody's going to mess around with these rankings, or if they do, it'll be short-lived. And anyways, I'm getting into the weeds there. I wanted to show you a little bit just a little bit of math here, and I'm not going to spend too much time on this because I don't want to bore you, but the basic idea is that there's these expectation equations that are used in the ELO formula, and I wanted to point out just this subtraction, RB minus RA. So this equation says player A has an expectation of beating player B based on the difference of their ratings. So if the rating difference is 400, you take this 400 or RB minus A. If that is 400, then you're going to have 10 to the power of 1 here, which is 10. So if you're playing a player who has 400 points better than you, then you presumably have a 1 in 11 chance, 1 over 1 plus 10, a 1 in 11 chance of beating that player. Conversely, if you are the other player, if you're the better player, then you have a 1 in 1.1 chance, or a 10 in 11 chance of beating the weaker player. So it gives you an estimate of whether or not you'll be able to beat that player, and based on that estimate and whether or not you win that game, it adjusts your score. With every game, it adjusts your score up or down accordingly. So that is about it. Oh, there is one more thing. I also put a team star option in there, and what that does is it basically takes everybody off teams, puts everybody back to a not random color. It actually, what it does is colors by red and yellow are always going to be the top two players. So when you do a team star command, the top player will be red, the next player will be yellow, the next player will be blue, and then pink, and then green. And the reason I did that is I figured, well, if people are going to do this, that gives you an idea. Let's go after the red and yellow players because they're the best players out there. Not another word, or if you will, let's avoid those players because they're going to kick your butt. And as me being probably the purple or green player down here, it's nice for me to know, like, okay, I'm gonna avoid that red and yellow player because I can't beat them. My skill levels is not good enough. Anyways, that is the teams command and the ELO ratings. Been spending the last several days working on this, and it works pretty well, I think. Now, I've only got a very small data set, but we'll see how it goes. We'll do some more testing. We need to get more games played to see how their algorithm pans out, but so far I think it's working pretty well. So let's end this recording if I can figure out how. Bye.